This is the back page of the ELO2 team test. The back page of the ELO2 team test. Okay, so this back page, it's pretty difficult, all right, but it's worth doing it and trying to understand it because it is going to be on the test, for one. This is kind of your A-level work, right? Your top tier A-level work if you could do these questions, okay? Then we have an extra credit problem that's kind of like a junior level problem that I want to go over. Okay, or IM3 I should say. So we have 3.7 times 8, which gives you 29.6. Okay, you can do that on your calculator. And then that's times 10 to the 8th. Now, you have to write your answer in scientific notation. And this is not in scientific notation. So I have to move my decimal back one. So I have to do 2.96 times 10 to the 9th. The reason I go 10 to the 9th is because I need one more factor of 10 to get where I need to be equivalent to that expression right there, the middle expression. Okay? Okay, number 12. I got a huge number, 5,760. What I'm going to do is I'm going to factor down that number. So first of all, I know that I could do 10 times 576. So many of you might have done 2 times something. That's totally fine. It's going to get you the same answer. 10 is 2 times 5. 576, just for the sake of simplicity, I'm going to do 2 times 288. And then 2 times 144. And then I actually know that 144 is a perfect square. Okay, so that means I can take the square root of 144 times 2 times 2 times 2 times 5. And that's going to equal 5,760. Now, 144, the square root of that is 12. Then, I can pull out a 2 because I have a pair of 2's. Listen, 2 times 2 is 4. The square root of 4 is 2. So if I have 2 2's, I can actually pull out a 2. And then left over on the inside is 2 times 5. Okay, 12 times 2 gives you 24. 2 times 5 gives you 10. So 24 square root of 10 will be your answer. All right. Now here we go, extra credit problem. This one is pretty cool. I like this question a lot. Okay. So we have to evaluate and solve for x. So our goal is to solve for x. And the way we're going to do that is we're going to use exponent rules. So first of all, what we're going to do is we're going to take these numbers, 9 and 27, and we're going to make the same base. We're going to make the same base. Okay? So here I want to do 3 to the power of 2. And that's to the power of 2x plus 1. Okay? Then that's going to equal 27 is 3 to the power of 3 to the 2x minus 1. So what did I just do? I made the same base of 3. So after that, I'm going to use the power to a power rule. So now since I have the same base of 3, I can do the power of a power rule, which would give me 2 times 2x plus 1. That's going to equal my base of 3 to the power of 3 times 2x minus 1. Okay? Now, I want to make a little side note on this extra credit question. here's where you have to make that leap of thinking. The goal for this question is to solve for x, okay? The goal is to solve for x. Since we have the same base of 3, you know that if you had like 3 to the 4th, for example, and that was equal to 3 to the x, you would know that that x has to equal 4. Because the left side of the equation and the right side of the equation have to be equal. So you know x has to be 4 here. So we're going to use this thinking. We're going to use this thinking to help us understand this one. If you need to rewind and explain what re-listen to what I just said, rewind the video. So now we're going to take this whole entire equation and we're going to notice that if the bases are the same, all I need to do is set the exponents equal to each other. Okay? In other words, the exponents have to be the same exact value in order for the left side to be equal to the right side. And then we solve. All right, don't make a mistake here. Solving should be very simple. We get x equals 5 over 2. Okay, x equals 5 over 2. All right, anyways, I hope that this helps. If it doesn't help, I'm sorry. It's an extra credit problem anyways, and you should be kind of relearning this stuff in IM3 maybe, but also just kind of reviewing exponent rules and radicals and roots and all that stuff in Integrated Math 3. So your junior level course. And then by then, you should be ready for the state test when you're a junior. Anyways, you guys are great. Thank you for watching. Adios.